Welcome to my YouTube channel where I share with you my journey towards data science. Hi everyone, today welcome to my YouTube channel where I share my experience as a trainee of data science. I'm currently on the week 7 and I just finished week 7 basically, and I want to share with you the project that I've done for this week, and it calls Guess Who's Make It? Guess who made it, not who's make it, but guess who made it, and basically predicts using neural networks who is gonna survive or not survive with heart failure. So I hope you enjoy it and have fun with me, and I'm gonna share with you what is possible to achieve in 7 weeks as a with this data science bootcamp. Hi, welcome. So this is the assignment from number 8 for week 7, and guess who's not making it? We use AI to predict heart failure mortality using neural networks. So as I always do, I look at the problem and the solution, I explore and get the data, I prepare the data, and I shortlist my models. Heart failure, really, it's something close to my heart. I've worked in cardiology and critical care nursing, cardiothoracic for a long time. So it's something that I really enjoy working on, and that's why this project was so close to my heart. And heart failure, basically, it's a clinical syndrome which consists of cardinal symptoms. What are cardinal symptoms? Maybe, your breathing, you struggle breathing, you might have ankle swelling, edema, or you might feel very tired. Obviously, these are general symptoms, so be aware that there are other diseases that might cause those symptoms, though, so don't panic if you're having the same symptoms, but obviously make sure that you go and see your GP and your doctor. Don't take this for granted, because there are loads of diseases that might cause similar symptoms, okay? And they can have also signs, for example, a very elevated jugular vein pressure, so you'll see your vein very salient, I think you have that word in English. So you can have some crackles in your lungs, some fluid in your lungs, and you can have edema or swelling arms and legs, and so on. And the key with heart failure is really identifying what is the cause, because it's crucial to decide which type of treatment you might have. So is it medication, is it lifestyle changes, or is it surgery? And it can cause by many different things. It can be caused, for example, by a virus and you ended up in severe heart failure. It could be caused by a heart attack. It could be caused by a problem in your valve. It could be caused by the pressures in your valves or arteries. It can be caused by loads of things. So, not everything is equal. So we went to the European Society of Cardiology and we looked at their terminology. It varies between sometimes the US and here in Europe, but there's 3 distinctive criteria in heart failure based on the ejection fraction. Basically, the ejection fraction is the amount of blood, or the percentage of blood that is it's pumped out from the left ventriculum. So basically from the side of the heart that pumps out into all your body, and what's the percentage? Normally you tend to have a normal ejection fraction if it's above or equal to 50%, and then if you're below 40%, you have a reduced ejection fraction, and if it's between 41 to 49, you have a moderate or mildly reduced ejection fraction. So this is important to kind of define the type of heart failure that you might have, and obviously this also varies. So I looked at their data, and they said that about 50% of patients have heart failure with reduced ejection fraction, and then the rest divide between mildly to preserved ejection fraction, but they are not divided equally. I think mildly reduced had more patients, I think. So I think this is just for curiosity and actually might be useful for our data as well. I just wanted to highlight that 2% of adults can have heart failure, and about 10% of those that are higher, that have an age higher than 70 years old, tend to have heart failure. So it's quite a huge percentage of the population above 70 years old, and a small population that is younger, but still quite significant. And heart failure patients tend to be hospitalized at least once a year, So you can imagine that this can cause quite a lot of disruption in your life and in your quality of life. And about so diabetic patients with heart failure tend to be are at 1.5 times higher risk of being hospitalized. So actually, being diabetes and have your diabetes under control might actually be quite important. So could we model your risk of mortality due to heart failure? So what we did, we used basic descriptive statistics, and then we did some neural networks using the multi-layer perceptron and backpropaganda. I forgot how this says. Let's see. So first we did extract and explore. So imported all the libraries that we did. Basically, we just add as we go along. And we, as you can see here, we've added our dataset, which is the Kaggle dataset. So this is not any, this is publicly available data that you can use for your exercises. Go on Kaggle, look at the heart failure, and you can use the same as I did. And then I import the neural network libraries as well. And then I explore this data. So this one's, I count my values, I looked at the information of the variables, the types of variables that I had, because that will be important then to prepare the data for my models. And then I describe my data. I also looked at missing values, but actually this data set doesn't really, it's not a real data set, because obviously real data sets have a lot of missing data. So this is a clean zero missing data. So actually this is great. It's very good for you to, once you extract the data set from Kaggle, have a look at the data, see if there is any elements that seem off. Is there anything that you might need to look up when you're trying to sort out your data and treat your data. Then I did some descriptive statistics. And under descriptive statistics, what I've done is I try to create something new and not spending a lot of time doing the same kind of charts that I always do. So I created a pandas series containing the data, and so I could create basically a categorical variable which would reflect the type of heart failure of my patients. And as you can see, we have a problem with this data already, because they might not generalize the overall population base. He actually is overrepresented by heart failure with reduced ejection fraction, which in practice that they have more risks of dying, right? Because they have much more complexity, their heart is not pumping very efficient now, so, and probably they have all the comorbidities on top, so actually it's overrepresentative. So actually use this data to test all the overall population with heart failure probably will not be very useful. But there you go. That's why it's important to look at the data and understand what's the population set, so then you can see the differences. So then here we try to see basically what were the types of heart failure with the types of age. In terms of neural networks, so that's the model that we chose to do. First questions that came off into my mind were like, well, how do I normalize data? Do I have to treat all the variables to numerical variables? Okay, how do I encode now the categorical variable that I created so I can add it on? So what I did was to do then the math first to see which ones had high variability. So to see which one had lots of outliers, and you can see that creatinine, phosphokinase, and the platelets as well as the time had a higher variability. So I thought about doing math to try and normalize it, but then I decided that actually these outliers were quite important to us, because these patients with high creatinines and high platelets might have higher risk of disease. Therefore, if we remove them, then we're not achieving anything. So I did instead min-max scalars, doesn't impact outliers as much, to normalize creatinine and platelets. I didn't normalize time because I didn't felt that was necessary. And then I did hot encoding for categorical variables to basically remove the type of heart failure and transform into a variable into 3 tables with 0 and 1s to 3 if I could integrate it within our file. But then I ended up dropping off because for some reason. I didn't know how to do it properly. Maybe, if you're an expert in data science, free to comment below and tell me about a little bit more about, how would you really look at these things and how can I've done it better. So then let's go into the split data. So first I dropped the heart failure. Don't ask me why. But I think it was because I thought maybe I need to encode it first and whatever. And then I split the data into independent and dependent variables. So I looked at the variable that event, and then the other variables in the data set except the data event, that event. And then I split the data into training and testing set. I've used, I've already passed it on, but basically I need a multi-layer perception, and I did add input layers. I've tried different ones. So here's where you spend a lot of time. So I think 60% of my time was spent doing this. And I decided to end up with units of 125, an input dimension of 12 because of the number of variables. And then I've tried to use, so I used Adam, and then I tried to use the learning rate as well, but I was just getting terrible results. So I've used Adam as an optimizer. And this is the things that I had. As you can see, my accuracy and value accuracy are quite equal, which indicate that I might not have any overfitting, which is great. And then I created a plot train loss validation just to see it. And you can see here that there's not much overfitting, which is great. Don't think that this was a straightforward. It took me a long time, so don't underestimate the time actually that you have to take in order to just study how it works. And then I made the prediction. So this is the things that I've done to print. And then I got a prediction and accuracy of 85%. Great. So I did a confusion matrix as well. So this is useful to understand your positive, the negatives, and it's so confusing. I'll have to write it down and to explain it best, because I always get confused about this. And then we put the ROC curve as well, so the operating characteristic curve, and we can see that we have an accuracy, a ROC of 0.1%, which is not too bad. But these are things that are really important, because obviously we don't want to be testing and getting people that have positive but are actually negative, or they are actually positive but they tested negative, especially in healthcare, right? And so in conclusion, find a way to leave types of heart failures and see if this improves my accuracy. I think it would. And then 60% of the time was spent optimizing the neural networks. And I think reading the book, I'll leave the link on the description below. Really made me understand how the model works and made more insightful questions. So I think it was useful, very useful to read the book prior. And yes, start early. I think this project took me 3 days after my classes. So we have classes 9 to 5, and it took me 3 days. So, don't underestimate the time that you spend doing these types of things. And obviously, you can check my code on GitHub. I'll leave the link below, and on Kaggle. And you can comment. Feel free to comment if it's something that you really like and you're really expert on. Feel free to comment, because I would love to learn more about how can I improve my code better. So I hope to see you soon, and check my other projects as I go along. I'm sure that in the next 5 years, in the next year, my code and my projects will be much more engaging and interesting. Take care. Bye bye.